of stuff.
Okay, so let's do it once again. Since we are first doing electricity and magnetism, so let's try again. So what is the nucleus of an atom?
Nucleus of an atom is um, a nucleus of an atom is is an another nucleus. It's like another nucleus, atomic.
Oh, come on. We did this one several times before.
I don't
Now,
understand.
so in an atom, there's a lot of things. The thing that's flying around a nucleus. This is a nucleus. Inside the nucleus, what do you have? Neutrons, which is not charged at all. You have proton is positive charge, right? Positively charged, right?
Mm.
But the outside flying around the nucleus, we have lots and lots of electrons. Is that clear? Any atoms will have this kind of structure. And let's say, for example, you have a piece of iron, something metal, a piece of iron. And when you touch it, you sometimes you can have like electrocution, right? Sometimes like
Oh, a shock, like a
shocked,
shock.
right? Shocked, right?
Yeah.
Why? Because a piece of iron, it can conduct electricity because it can let the electron flow through very easily. However, if you touch a piece of wood or a piece of plastic, can you ever get shocked? Never,
Uh,
right?
No.
Mm. So, why? Because a piece of wood or a piece of plastic does not conduct electricity. Because why? It does
Wait,
not.
so oh, wood and plastic cannot conduct electricity, right?
Very, very poorly. They don't do that very well at all. So that's why
But
we
even if they can, they do very poorly, right?
very, very, very poorly. So it's considered like they cannot.
Okay.
Okay. So they cannot, they don't allow electrons to flow freely, just like a piece of iron. Okay. So that's the electricity. Okay. But we need to understand what magnetism is as well. So, magnets, how they attract and they pull away something, right? Okay, let's go to magnetic fields. We'll talk about properties of magnets. Magnetization of iron and steel. It means that if you have a piece of iron or a piece of steel, you can turn them into magnets too, easily. Like, for example, you rub a piece of magnets on a piece of iron, just rub it there, and then a piece of iron will become magnets. I do that all the time. Like, for example, you know what a screwdriver is? A screwdriver. You know what a screwdriver is?
Yeah.
Okay, so it's a simple trick of people because sometimes a screwdriver, there are screws, right?
Mhm. Yeah.
But these little things, sometimes they just run away and then they fall on the floor. So the trick here is you're gonna rub a piece of magnets on the screwdriver,
And then what will happen?
and then this piece of iron on the screwdriver will become magnetized. So
Okay.
it become a magnet itself. And you can easily attract these squirrels so they won't run away that easily. It's a
Mm-hmm.
very simple and very popular use. I
Mm-hmm.
mean, it's a very good trick you can do. And of course, because it become magnets, all the screw will stick to the screwdriver. You will not lose them again that easily. You understand what I mean, right? Well, it might be easier if you meet me and we do have it in labs or whatever. Anyway, we talk about magnetization of iron and steel. You can turn iron and steel into a piece of magnet. All right. And we talk about magnetic fields. Like imagine if you are very near to a piece of magnet,
Then what will happen?
anything that you wear, for example, your phone, if you are very near to a magnet, your phone will stick to a magnet. But if you are not close enough, it won't do, right? Okay, so if you go to a hospital, there is something called MRI machine. It's a machine inside a hospital that people can detect things. And they say that you should never bring anything metal into this room.
Why? Oh,
No
is it
phone.
like it will stick very hard,
Yes,
and you can't take it out unless
because
you off
inside here
the.
is there's a massive magnet inside of this machine. You should never bring your phone there.
But
No,
what?
no
But what kind of
watches.
magnet is it?
Sorry,
Is it a south one or a like
sorry.
which kind of magnet is it? Is it a south or north one?
I think one is north, one is south. I'm not so sure. I'm not an expert in this machine though. But anyway, I know there's a huge magnet there, and you're not allowed to bring anything metal in this room. It could be dangerous, you know. So no guns, no watches, no coins or anything metal. Sometimes if your pair of glasses, it's metal, you should not bring into this room either, you know? Anyway, because the magnetic fields in this room is very large. So what is a field? It's a space around a magnet in which metal things will be attracted to the magnets. If you are out of this field, you are out of the area that you will be affected. So you're good. Understand what magnetic field is?
Yeah.
Right. So if you're far away from the magnet, you won't be affected. But if you are quite near to it, you will feel it, right? If you wear something metal. Okay, so we also talk about the Earth magnetic fields. Of course, our Earth, our home world of Earth. It's a massive magnet. Because why? Core of the Earth. Okay, you learn in science that inside the middle, the core of the Earth is actually a lot of iron, right? It's molten iron floating inside of the core of the Earth. And because of this,
Mhm.
it makes Earth a huge magnet. So the Earth actually has its own magnetic field. Okay. Like for example here, you can see the Earth magnetic field.
But what is it? The core of the Earth is a whole magnet, right? I heard it. So,
Because of the iron flowing inside of the core of the Earth. Yeah.
oh, that's cool.
Very cool actually. So you know the North Pole and the South Pole
So
actually,
if I just take a magnet and then I put it on the floor, will it stick on the floor?
it will.
Really?
I tried. Yeah.
Really?
Yeah.
I want to try for myself.
Well, let's hope that you won't break anything. Anyway, so I was talking about the Earth's magnetic field. You can see here that this is the North Pole of the Earth, the South Pole.
Mhm.
You know the compass, right?
Mhm.
Okay, anyway. So um, we have a massive magnetic field around the Earth. Sometimes they protect the Earth against like a lot of space rocks and things like that. And a lot of the time they protect the Earth against like solar storms. You know, the sun actually emits some storms, and because
What does
of
emit
things,
mean? What
sorry,
does emit mean? What does emit mean?
what does what?
What does emit mean? The
Emit,
word that you said.
like they release, the sun release or emit to send out something, or the sun releases a lot of rays. Sometimes they become solar storms, and sometimes they can damage our satellites or our internet. Sometimes they can damage our electric system, like network, like the national grids. So that's why sometimes there can be power cuts on the days where solar winds it's strong, right? Solar winds can actually sometimes affect humans' health too. But thanks to the magnetic field of the Earth, it kind of like block or defend the Earth against those solar winds. It's not perfect, but it does help a lot.
Mhm.
Okay. And then practical work is plotting lines of force. And we'll see it later. All right, please read this one. Property of magnets. Okay, just read A, B, C, and D first, and we'll see, okay?
Summarize facts and state.
The law of magnetic poles summarizes these facts and state. So let's say the poles North Pole and South Pole, right? Like poles will repel, and unlike poles will attract. Like for example, if you have two magnets, right? Look at this picture. So the North Pole of this piece of magnets will attract the South Pole of this iron nail, right? Is it understandable? And the north of this iron nail will attract the south of this next iron nail. However, if you have two north facing each other, they will repel each other. They will not attract. Or if you have two south, they will also repel. Is it understandable?
Mhm.
Okay, as their separation increases, it means that if they're far away from each other, of course, the force between the magnetic poles will decrease. Like for example, if you have two pieces of magnets, if they are far away from each other, you won't see any attraction. You won't see any repulsion. It's a noun form, yeah. You understand what it means, right? Hello?
Yeah, I do.
Okay,
A bit.
so we have a compass. It's a device that we can use to tell which direction we are going. Have you ever seen it before?
Is it a compass?
Yes, it's a compass.
Like it points, like which
You can
direction
use
we.
your phone. You can download an app called Compass, and you can see
It's
which
already there in
direct-
your phone.
Sorry?
It's already there in your phone. You don't need to download. I think so.
Oh, it's already there. Okay. And based on that, you can see which direction you're going. It's quite accurate. People use these compass so they can know like their home. Where's their window looking at? Which direction? Like for example, my balcony actually looks to the north, for
Mm-hmm.
example. Mm. And imagine in the old times when we're at sea, around
Mm-hmm.
you is a lot of water, sea water. If you run in the wrong direction, you're screwed. You're gonna end up like fish food. So you have to go in the right way, and the compass is a life-saving device in the old time. And imagine that the flow of the ocean sometimes is unpredictable depending on the weather, and also the winds are unpredictable too. So you have to see where you're going to using a compass and some star system. You look at the sky and then you do some calculation, things like that. But that is the old times. Now we do have GPS.
Mm-hmm.
So we don't
GPS.
need this thing anymore. But anyway, a piece of history here is a compass. They say a magnet can therefore be used as a compass. Why? Because if a magnet is supported so that it can swing in a horizontal plane, like look at this one. This piece of iron here,
Which one?
this black piece of
Oh,
iron here is actually a magnet itself.
oh
And it
wait.
sits and it sits on
I
here.
thought it's just like a string thing.
And actually, this face here is a horizontal plane we're talking about. And this black piece of metal here is actually a compass.
Mm-hmm.
And it allowed to come to rest with one pole, the north seeking or the end pole, always pointing roughly towards the Earth's north pole. So this one will always pointing very relatively to the north pole of the Earth. But you have to be patient because sometimes it takes like a few seconds to turn to the right direction. Okay, is it understandable?
Mm-hmm.
All right, good. All right, so basically, what is magnets first? Magnets are basically materials such as iron. Steel is basically 95% iron and 5% carbon. So mainly they're just iron. Nickel and cobalt can also be used as magnet too. So these are called ferro. Ferro mean Fe, iron. Remember?
Mm-hmm.
Ferromagnetics. Not all metals can be used as magnets, okay? Because some will not be able to form magnetic fields. Like for example, if you have like aluminum, you cannot use it as magnets. Titanium,
Isn't it metal?
sorry?
Isn't it metal?
Yes, these are metal, but sometimes there are some metal that you can use, but some others no. Because if they are not ferromagnetics, they cannot be used. Like these things can be used as magnets, but titan, gold, nah. Titan, gold, aluminum, nah, you don't use them to form magnets. Okay.
Mm-hmm.
All right, let's move on now. Magnetization of iron and steel. They say that chains of small iron nails and steel paper clips can be hung from the magnets like this. These are paper clips. These are iron nails. Each nail or clip magnetizes the one below it. And the unlike poles so formed attract. Like here, the magnet actually magnetized this iron nail and In turn, this iron nail actually magnetizes another iron nail. And this iron nail in turn magnetizes the other one. So it's like contagious, you know? So basically, this iron nail now, the south pole of this iron nail will attract the north pole of this magnet.
Mhm.
And now this north pole of the iron nail will attract the south pole of the next iron nail. So the same thing happens here to steel paper clips, right? Remember, unlike poles will attract, but like poles will repel, okay? And if the iron chain is removed by pulling the top nail away from the magnet, like for example, this one, you remove this iron nail, you remove it, this whole thing would just collapse. They fall down to the ground. Why? Because magnetism induced in iron is only temporary. They're not forever. They are not permanent. Okay?
Mhm.
Because if you remove this iron nail, now the source of the magnetism is removed, right? So these 1, 2, and 3 iron nails will just fall down to the ground. And remember, magnetism is only temporary.
Mhm.
Induced magnetisms is only temporary. So when the same is done with the steel chain, it does not collapse because magnetism induced in steel is permanent. But why? It depends also on the material, I think. So these are steel paper clip, okay? So if you remove this first paper clip, it seems that the other 3 still stick. It does not collapse.
Mhm.
So it appears that in steel, magnetism induced is permanent.
Mhm.
Okay, why is it so? They say magnetic materials such as iron that magnetize easily, but at the same time, they can readily lose their magnetism. Or in other words, they easily demagnetize because they are said to be soft. Those such
Okay.
as steel are harder to magnetize, but then they stay magnetized forever. They are called hard materials. Both soft and hard types have their uses. Like for example, if you have steel and you magnetize it, it can be used to make permanent magnets. So you can use this magnet forever for a lot of uses. However, there are sometimes you need to demagnetize and you need to magnetize again.
Okay.
All right, so it depends on the use. We can use steel or iron. Okay. All
Okay.
right, so let's talk about magnetic field now. The space, okay, like I tell you, what is a field or magnetic field? It's a space surrounding a magnet, close enough to the magnet, where it produces a magnetic force. It's called magnetic field. You need to be close enough to a magnet in order for it to attract or repel you, right?
Mhm.
All right, the force around the magnets can be detected and shown to vary in directions using apparatus in this figure. Okay, so you have a bar magnet here.
Line of
And
force.
sorry,
What is it called?
Well, the force here is actually goes in a line, like a called line of force. And
What,
it's
what is it?
always from the north going to the south, okay?
Mm-hmm.
Remember, always go from the north to the south. The line of force here. It's very funny because the North people always try to go south, right? You know, sometimes I
Uh,
give sometimes I give example that is so political or so wrong. Oh my God.
I don't get what you mean by that.
Because I think in most country, the North people always try to go to the south.
Why does the North?
I mean, it's something very similar to this one. The North always go toward the south, you see?
Mhm.
Anyway, let's look at this one again. This is the experiment
But
they're
oh,
trying to show you. If a floating magnet, okay, if a floating magnet is released near the end pole of the bar magnet, it is repelled to the S pole and move along a curved path known as a line of force or a field line. This one.
mm-hmm.
It moves in the opposite direction and if its south pole is uppermost.
Mm-hmm.
This is a bowl of water. This is a magnetized steel needle or rod. Anyway, just remember that it's gonna go like the line of force gonna go from the north to the word towards the south, right? It's useful to consider that a magnetic field has a direction, of course, and to represent the field by lines of force.
Mm-hmm.
So conventionally, everyone agrees. It has been decided that the direction of the field at any point should be the direction of the force on a north pole. And to show the direction, arrows are put on a line of force and point away from a north pole towards a south pole. So it's always away from the north pole, but then it's always go towards the south pole. Know what I mean? That's
Mm-hmm.
why I'm like, why do the north people always leave and they try to go down south?
Huh? Why?
I mean, you can ask your dad. Funny.
Why ask my dad when you know the
But
answer? Like,
seriously, but seriously, a lot of people from the north, they always try to go down south because they think that the
and the
south.
South goes to the North, right?
Well, sometimes, but most of the cases, the north go to the south, I think.
Like Russia goes to Vietnam.
Think so. And Chinese going to Vietnam to have vacation, for example.
I think they're all going for vacations, nothing else.
All right. There you go. Practical work, plotting line of force, plotting compass methods. Hmm. I don't think you need to do this one anyway. Let's say that, okay, there's a piece of magnet, right? And you have iron, like pieces of iron, and
Mm-hmm.
you just basically sprinkle the iron around these magnets. And after a while, you see them looking like this.
Why does it look so weird? Look so
Well,
fun.
think about it. Think about what we have here. Two neighboring magnets. The north always point toward the south, right? This is the line of
So the
force.
north connect to the south and then the south connect to the north.
Mm. But it's always like leaving the north here and entering the south here, right? But if you have like two poles, like north-north or south-south, they will leave each other, right? They will not like attract like this. So the north-norths, they will just leave away from each other like this. Okay.
Mhm.
Of course, the Earth has its own magnetic field, like I told you.
Okay.
And it has its own line of force due to Earth's field. And look at this one.
So the earth connect to each other.
What do you mean there's only one Earth?
Wait, what the?
Anyway, and remember that the Earth's geographical poles and its magnetic pole do not coincide, okay? So it means that the North Pole is not exactly where the magnetic north is located.
Okay.
That's called delineation. Declination. All right, let's try this question. Which one of these statement is true? A magnet attracts what? A, B, C, or D, or E?
Magnet that attracts iron and steel,
Correct.
right?
Yes, correct. And I don't think you need another one. So let's go to static electricity. This is unit 35. Okay, so what is this word static?
Like electric,
Static means they
like
stay in
visible
one
electricity.
place. Stay in one place.
Stay in one place.
Static mean they stay in one place. Okay. Let's imagine that in the winter time, sometime when you touch the door handle, which is let's say metal door handle, you get shocked, right?
Mhm.
Because the door handle itself is metal and it has its own static electricity. It means the electricity just stay there and it waits until someone touch it.
What will happen if someone touch it?
Of course, they got shocked.
I wonder what happens when someone touch it.
Well, it always happened during, especially the winter time.
A winter.
I mean, in winter time, it seems that the static electricity happens much more than during summer. Anyway, so we'll talk about this one, lightning. Okay, this is a flash of lightning. And this is nature's most spectacular static and electricity effect. Because look at the ground and the sky. The ground and the sky is like a north and a south pole of a magnet. So when it's about to rain, of course, the cloud and the earth. There's a space, the air in between, right? And sometimes when rains happens, you see a lot of these lightning. These are spectacular. It looks beautiful, but deadly as well. Because these are electricity, okay?
Mhm.
It can reach up to 10 million volts, okay?
How much is 10 million volts?
You know that the electricity in our home is 220 volts, right?
220
220, yeah.
daily or monthly or what?
But then when you get shocked, it's already very bad, right?
Mhm.
But
So if
lightning,
100, if 10 million volts can burn you alive,
of course, it can
like
kill you
literally like turn
instantly.
you
It can
into
burn
ashes.
you, really. So that's why lightning is super dangerous. It's
So that's why in swimming pool when there's heavy rain, they always tell people to stay indoors,
stay inside. That's
stay
why,
inside.
just stay inside. Don't stay near to trees, okay? Why? Because the tall objects are much
Get
more likely to attract lightning, okay?
so you are more likely to get attracted to lightning more than me because I'm short.
When you are under a tree. When you're
If
under
that's
a tree,
true,
yeah.
my friends have more possibilities of
What do you say?
getting struck as a lightning.
All right, so we were talking about positive or negative charges. Okay, let's say you have a piece of cloth, okay? Like clothes, cloth, whatever, and you rub it. You rub a piece of cloth on each other, it will become magnetized somehow.
Mm-hmm.
And if it is hung up and another rubbed strip is brought near, there's going to be repulsion. They're going to repel each other. Have you ever
Okay.
played with plastic bags?
Yeah, I do.
Play with plastic bag, rub them together, you will see some thing they attract. Sometimes they attract, sometimes they
Oh yeah,
repel.
I heard I saw it on TikTok like there's like a thing like if you rub yourself with another person together, you get electric shocked.
Hmm.
What is that?
They become okay, of course, there's static electricity on those things if you rub them, okay?
Mhm.
Okay, let's just say, what is this? This is a rubbed polythene strips, and this is another rubbed polythene strips. So these are like charges at these, and of course they repel. If
Mhm.
they're unlike, they will attract. So when you rub things together, sometimes they become magnetized temporarily, okay?
Okay.
Like for example, plastic bag. Okay, clothes containing nylons often crackle when they are taken off. Like for example, these sport clothes. Do you have them? Sport clothes?
What
Like
sport?
clothes you use when you play football or play any sports.
Yeah, I do.
Like, yeah, and when you take them off, they crackle. Like you can feel like this tiny sound, right? Crackle when you take them off, right?
It's like the water.
Well, let's just check these things out.
I do not know what you mean by that.
Okay, these kind of clothes, you have them.
Yeah, I don't, but my father, I think, no, I don't.
Okay, these are actually nylon, and these clothes contain nylon material in there. And when you take them off, sometimes you hear the little sound like crackle, like tick, tick, tick. That's what means like crackle. Okay, when they're taken off, and we can say they are charged with static electricity.
Mm-hmm.
The crackles are caused by tiny electric sparks, which can be seen in the dark. I've never seen that in the dark. Maybe I've never been in the dark and removed my clothes. Pens and combs made in certain plastics become charged when rubbed on your sleeves and can then attract scraps of papers. Do you use your combs to comb your hair?
I don't use a comb, but my sister do.
Okay, ask her. Sometimes if she combs her hair, does the comb become magnetized and it can attract pieces of paper? Answer.
Wait, magnet can attract paper?
Yeah,
Huh? Are you for
because
sure?
if you rub your hair, if you use a comb to comb your hair, sometimes it become magnetized as well. It can attract pieces of paper temporarily, okay? Okay. So the same thing happens to rubbed polythene strips. Same thing. Okay, this shows there are two kinds of electric charge. That on
Mhm.
cellular, okay, the one that is positive and on polythene is negative. So like charges, which mean either they are positive or negative and negative, they will repel. And if they are unlike charges, which is positive and negative, they will attract. You know this one, right?
Mhm.
Okay, clear?
Clear.
Okay, the force between electric charges decreases as their separation increases. It means that if they are far away, the forces between the positive and negative will not be strong, right? They need to be close enough, isn't it? Is it clear? They need to be close enough, yeah? Okay, now let's move on to the next one. We talk about charges, atoms, and electrons. What's that? See, we talk about the nucleus of an atom again. This is a hydrogen atoms, and there's one proton in there and one electron's moving around the nucleus randomly, right? We learned this one in chemistry. Do you remember?
I did.
Of course you do. And this thing inside of a nucleus, it is positive charge, the protons. And they
Mm-hmm.
have to be surrounded by an equal number of electrons, which is negatively charged.
Mm-hmm.
Okay. All right. So this practical work, I don't think you need to do. Electrons, insulator, and conductors. So we talk about things that will conduct electricity or conduct electrons, but there are things we will not do that.
Mm-hmm.
Like for example, I told you plastic and wood, they will not give you shock because they are insulated.
Bad. They react badly.
Yeah, so they are considered as insulators.
Mm-hmm.
But if you have metal stuff, they will surely conduct electricity, right? Because they are conductors. All right, it's good to read this thing, I think. Okay, let's just read this one. Electron, insulator, and conductors.
Okay.
Let's just read them.
An insulator, all electrons are
Bound firmly.
bound firmly to their atoms. In a conductor, some electron can move freely from atom to atom. An insulator can be charged by rubbing because the charge produced cannot move from the rubbing occurs. The electric charge is static. A conductor will become charged only if it is held with an insulating handle. Otherwise, electrons are transferred between the conductor and the ground via the person's body. Good insulators include plastics such as polythene,
Cellulose acetate.
cellulose acetate,
Perspex.
perspex, and nylon.
Nylon.
All metals and carbon are good conductors. In between are materials that are both poor conductors, and because they conduct to some extent, poor insulators. Examples are wood, paper, cotton, the human body, and the earth.
Luckily, the
Water
human body does
conducts.
not.
Water
Luckily,
conducts. Huh?
sorry. Luckily, the human body does not conduct electricity very well, you know. Luckily,
What if it does? We die.
well, you die easier
Cool.
because you know human body actually like 70% water, right?
Hmm.
Okay, and there's a lot of things inside the human body as well. Water conducts, and if it were not present in materials like wood and on the surface of, for example, glass, they would be good insulators. And dry air insulates well. But when it's about to rain, it's not dry, it's wet air. You have water in there. So wet air, when it's about to rain, is dangerous. Why? Because you can get lightning strikes.
Okay.
Mhm. Right, good. Okay, you have metal spheres here, charged polythene strips. So these strips are charged, negatively charged. And
Mm-hmm.
so you put it near, oh, these insulators.
Mm-hmm.
Never mind. Let's move on now.
Okay.
Okay, they were trying to explain something for you about lightning conductors, okay? You know, tall buildings always have these kind of
Yeah, I know. Like
yeah,
the
right?
things that so like sometimes like I heard like it have like the thing so that it in case
Spikes,
if they
very
if
tall
like the
spikes.
lightning hits
Hmm.
the building, then it collects the electricity, and then after that the whole building get like um outburst or something, like like uh what is it called?
Anyway, so tall building have these spikes and it's basically pointing towards the sky. Okay, so basically when there are thunderclouds about to rain and these spikes are very long, they will connect to the earth, okay? There's some metal plates in the ground. Because when it's about to rain, I told you, wet air actually conduct electricity, right? So it can conduct these electrons, positive and negative ions, things like that.
Mm.
So in these spikes, electrons are repelled back to the earth. However, there's a lot of positively charged in here. And because of this one, it attracts the thundercloud and it can attract lightning.
Uh-huh.
And when the lightning strikes, everything will go down to the ground and everyone is safe, no problem. It's better like that because you are using these spikes as bait. B-A-I-T, bait. You know the word bait, right?
Yeah.
It's like because of these spikes, people don't have to worry too much of lightning because they know the lightning will hit these spikes, not them. So it's used like a kind of insurance, you know. So the
Mm-hmm.
spikes will take the lightning for you. Understand?
Mm-hmm.
Right. So another examples here is a stream of water. It can be bent by electrostatic attraction as well, and things like that. And talk about danger of static electricity. All right. Can you read this thing? Dangers of static electricity, lightning.
A tall building is protected by a lightning conductor consisting of a thick copper strip fixed off the outside of the building, connecting metal spikes at the top of a metal plate in the ground.
Mhm.
Thunderclouds carry charge. A negatively charged cloud passing overhead repels electrons from the spikes to the earth.
Mhm.
The point of the spikes are left with a large positive charge.
Mm.
Charge concentrates on sharp points, which removes electrons from nearby air molecules, so charging them positively and causing them to be repelled
From the
from
spike.
this. This effect, called action at points, result in an electric wind of positive air molecules streaming upwards, which can neutralize electrons discharging from the thunderclouds in an lightning flash. If a flash occurs, it is now less violent and the conductor gives it an easy path to ground.
Exactly. So basically the spikes and this pole, these spikes, this rod will lead this lightning to the ground. So the
Mhm.
flash will become much less violent and it's actually safer for people. You don't want to be struck by lightning, right? Nobody wants to be struck by lightning.
Mhm.
Anyway, refueling.
I heard that Flash got struck in from lightning and he got speed powers.
Hmm. Okay,
I'm
there's
gonna
there's another thing I want to tell you.
hmm?
Chain and trucks.
What is that?
Okay, there's a reason why trucks have some chains hanging at the back of them. Have you ever seen these things?
Where? I
Yes.
haven't.
Sometimes there are trucks, like there's a lot of trucks, they carry a lot of things, they carry stuff, they carry items in and out of the city. However, as they move, of course, there are static electricity on the truck, which can be dangerous because trucks have to be refueled, right? And you know that petroleum, when it catch on fire, is super dangerous. It can burn and then kill people, right?
Mm,
So why did they have these metal rods here? Because it will lead those static electricity down to the ground. So the
mm,
truck will be safe to refuel.
mm.
Okay, let's read this thing. Refueling.
Uh, refuel, refueling.
Refueling.
Sparks from static electricity can be dangerous when flammable vapor is present. For this reason, the tanks in an oil tanker may be cleaned in an atmosphere of nitrogen. Otherwise, oxygen in the air could be promote a fire.
Mhm.
An aircraft in flight may become charged by rubbing the
Rubbing
air.
the air. Remember, because these vehicles, they move, right? So the air, they rub on the air. So the same thing like with trucks, they move on the roads. They could have static electricity as well. Mhm. It's tires. Okay, it's tires of the tire. These are the tires of the trucks or of the aircraft are made of conducting rubber, and it lets the charge they pass harmlessly to the ground on landing. Otherwise, if you it there could be an explosion when the aircraft refuel.
Mhm.
What precaution are taken at petrol pumps when the car is refueled? You're not allowed to smoke cigarettes, not allowed to ignite anything when
Inside
you
a
are
plane,
near to petrol pumps, right?
like it will explode.
Come on, petrol, they catch on fire easily.
Oh yeah, it catch on fire.
And like I told you, these things the same thing. These chains actually lead or the electrons to the ground, right? So basically they can flow harmlessly to the ground. And as a result, the trucks are no longer having that static electricity. So when they start to refuel the trucks, there won't be a danger of fire, right?
Mm-hmm.
Understandable?
Mm-hmm.
These things are serious, okay? People have to
Okay.
take it very seriously. Now,
Mm-hmm.
operating theater, you know what operating theater are?
Mm-hmm.
Operating theater are basically the thing inside here. Know what it is?
What?
Inside a hospital, sometimes you have to open up people, right?
Yeah.
These are called operating theater, where surgeons, doctors or surgeons, they will open up people.
Mm-hmm.
Okay, dust and germs or bacteria and dust are attracted by charged objects. So it's essential to ensure the equipment and medical personnel are well earthed. It means they have to touch the ground or their body or the equipment they use should not have static electricity, okay?
Mm-hmm.
Computers are also similar. They require similar anti-static conditions as they are vulnerable to electrostatic damage. Imagine that the chips inside of your computer, sometimes
Mm-hmm.
electrostatic can damage your chips and it can damage your laptop, right?
Mm-hmm.
And
Yeah.
sometimes it can catch on fire, something like that, very dangerous.
Mm-hmm.
However, there are uses of static electricity as well. What can you use it for? Photocopier, viewer, flush precipitation.
What do you mean by that?
Hmm. Okay, so basically, one thing I can show you that can use static electricity. These are, you know, these things, right? The broom, right? You know,
Mm-hmm.
the classic broom that people use for dusting, right? Ever seen them? How about these things?
Mm-hmm.
You can use these kind of device to dust. It means to remove dust from your stuff in your house. What do they do? Actually, because they are charged, because they move around, right? So they can attract a lot of dust into them, which means they can remove a lot of dust from your table, from your objects inside of your home for you. Isn't it pretty? Okay, inkjet printers and photocopier also. Okay, you have the file, you can read them. And I think the next time we can work on electric fields. Okay, but this one you read them, okay?
Okay.
Okay, next time we work on electric fields.